Okay, so you remember, treat this as some, not all properties, but just a commutative property mainly. Let's just say we want to create a big vector, or we will go with v1 v2 only. It's fine, much easier. Okay, so if I check np dot product of v1 comma v2, okay, this is what it is. And if I swap the places, v2 comma v1, that is also fixed. So from this, can I say they are equal? Okay, they are equal to. That means dot product is commutative. Can I say this?
Yes.
Okay, and not only this, even the matmul. So matmul, matrix multiplication, that also will give you the same value. So using this, you can say dot product is commutative. Okay, and now let's just say we will explore a little bit on this. Let's just say you have a vector, okay, and for that vector you want to okay, let me quickly check type of vectors. Negative vector palette, this theory you can read it up by yourself. Properties, okay, this property we evaluated. Okay, um, operations on vector, addition of vector, subtraction of vector, scalar, multiplication of vectors, component of vectors. Okay, scalars, vector difference between scalar. Okay, fine, more or less covered on the vector part. Okay, so this is all about vectors. Okay, and the next thing is we wanna look at how we are going to um, see the cross product. Okay, we have something called cross product also. Okay, that.
Sadi,
Mhm.
uh, is there anything like modulus of a vector?
Modulus of a
Hello?
vector. Modulus of a vector is the magnitude value only, norm only.
Yeah, so, acha, is the norm only. I
It's
mean,
a norm only.
so in NumPy, they call it as
Norm.
norms. There is no functionality called mod or something here, right?
No, no.
Okay.
See,
Okay.
modulus in our normal mathematics we studied was absolute value, correct?
Yes.
Mod
Yes.
value in our Python is remainder. Okay, remainder
Oh.
because you use modulus symbol. Mod
Okay.
value in
Okay.
our linear algebra is norm value.
Okay. Okay.
Okay,
Okay. Okay. Thank you.
okay, all right. So up until this point, we what we saw was dot product. Now we are gonna see a cross product. Now cross product you have to understand. Um, okay, cross product of vectors. Cross product of vector. So for this particular matrix is again a combination of vectors. Okay, so you can see vector components are represented in a matrix. Okay, whatever it is. So cross product of vector is nothing but, here there are how many vectors there are. Okay, there are two vectors a and b. Okay, which is represented in the form of a1 a1 b1 c1, a2 b2 c2. Those are your coordinate systems. Ijk represent your actual coordinates. Okay, but whatever the scene is, but just understand your vectors cross product means you have to multiply this determinant, what do you call, you have to skip that particular column and take the b1 c2 minus c1 b2, and then skip the second one. Okay, skip the um, second column, and then a1 c2 and a2 c1, and then skip the third. For third coordinate you skip that particular column and take multiplication of a1 b2 b1 a2. So you take the differences of that, then you will get the final value as cross product. Okay, it is used, actually it is used is to determine the product of magnitudes of two and sign of angle between them. Why do we use cross product is, see, dot product is clear, dot product is just the multiplication of the vectors. But here if you wanna take only the product of magnitudes and sine of angle, not the cos of angle, dot product will give you cos of angle. But if you want to also calculate sine of angle, then you do a cross product. Okay, that is just mathematically you can just brush up your knowledge. But here, um, lucky for us, we have very straightforward process. We have something called cross. We just pass v1 and we get v2. Incompatible dimensions for compatible must be 2 or 3. Okay, for again for cross product you have to have vectors of um, 3 dimensions only. Why? Because too many dimensions, I think it won't allow, the package itself won't allow. um, okay, so you just understand this, although you are not going to use cross product much. Okay, so you'll get the cross product like this. Even in computer vision you mostly use dot product only everywhere. Okay, so dot product is important for us. Cross product, just it's good to know information. Okay, so cross product will give you either it has to be 3 dimensional or 4 dimension, sorry, or 2 dimensional. Even if I add one more dimension extra, let's test it out, you won't get it because you have to have 2 or 3 only. So the maybe the calculations will complicate. Okay, that's why. Anyway, so for cross product you just understand that it will give you an array only. This is another difference. Okay, cross product will give you an array, dot product will give you only a magnitude value 50. Okay, you'll get only one scalar value. Here you'll get complete array itself. Is this clear?
Yes, yes, Sadi.
Okay, now some vectors can exist with complex numbers also. Although I might not be showing you, or if you want I'll show you, but the thing is you won't be using it. Okay, all your problems are in real values only. Okay, the next thing is I will show you complex numbers, but before that I want to show you something very important. So we have something called concept of transpose. Okay, what is the transpose of a matrix? Or a transpose of a vector? Transpose of a vector is nothing but your rows are converted in arranged in the form of a column, right? So if I type np dot v1, it looks similar. Okay, here v1 is 325. Okay, but if I calculate, okay, first is equal to numpy array of this. Okay, then v1 dot, we have something called, first let me execute. Okay, and then we have v1 dot endim. Okay, let me see. Okay, endim of, sorry, v1 dot shape. Yeah, v1 dot shape. So even before I explain this, let me move it to below. So here what we are trying to see is transpose of a array. So this is our array. I have redefined the same array. Okay, and I'm looking at its shape, and I want to see v1t. Okay, for easy understanding. So v1t dot shape we want to check. So before transposing this is what it looked like, and after transposing this is what it looks like. So although it shows the rows are the same, or sorry, the dimensions are the shape of the array is the same, but actually it has gotten transposed, which means the rows have converted into columns. This we can visualize much better in a matrix. This there also I will show you how to obtain a transpose. Okay, here it may not be that much clear, or let me think, let me do one thing, let me create a multiple dimension array. In order to create multiple dimension array, we have something called nd array. n dimensional array. Here I will mention I want 10 values, and I want what type of values those to be. Okay, I want the values to be int values. Okay, into 16 values, into 16, into 32. You, I think you already know, into int stands for integer, 16 stands for length of that integer. Let's just say 0 is my integer. In normal decimal value it is 0 only, but in binary format, in a byte format, it is represented like this. But if you say n to 16, this is what it would look like. Okay, so I don't want my length of my each number to be very high, that's why I'm specifying n8, or even n8 should be fine. Okay, so this is my one array, and another array also I'm creating, n dimensional array, where in which I'm saying there are 10 values, but those are also um, integers only. So if I run this n, so I have gotten, see, randomly it has chosen the values. Don't worry why the values are different. Randomly it creates. Okay, so see, randomly it chooses the values. Don't worry about the values themselves, but try to pay attention to how you can get the transpose. Okay, transpose of a I will calculate first, but I will multiply b just only so that okay, um, mul- n dimensional array. Can I define the endim? um, One moment, I want to arrange them into dot. Okay, fine, here let me try dot uh, arrange them into 2 comma 3. Can I do that? No. What if I try n by 2 comma 3? Increase the dimensions such that it's empty. Okay, np dot arrange of, one moment, so I will try to arrange them in different shape, or maybe I will try to reshape. Hold on. A dot reshape of 10 values you can arrange in 2 comma 5 values. Okay, yeah, much better. Okay, dot reshape of, I'm creating and then I'm reshaping. Okay, if I reshape, then you will be able to see the, this is what a looks like, this is what b looks like, randomly value chosen value. If I transpose a, now see, rows became columns, notice. And b, if I transpose np dot transpose of b, that also gets transposed. Is this clear? So transpose is used to calculate the transpose of a vector or a matrix, and reshape is I'm trying to arrange them into multiple rows and columns. Originally it had only one row with multiple columns, sorry, multiple one single row with multiple columns. Yes, I'm correct. So multiple row, single row, multiple column. Now I made two rows, multiple columns, so that way. Is this clear? Don't worry about the reshaping part, just understand the transpose is just converting rows into values. Is this clear?
Yes, 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 yes.
Okay, all right.
So there is no for a row vector or a column vector. I mean, the way here it is showing the order of this
Mm-hmm,
vector, right?
mm-hmm.
But for a row or column vector, in the it cannot display, but it will be existing there.
Correct. Absolutely, absolutely. It won't display. It can't display properly, but it has transposed. That is what I was trying to make the point. So, if this is clear, we can move on with the next concepts. So, next thing, whatever we will be learning, will be matrices. No more vectors. Are these vectors clear?
Yes, Sandeep. Transpose is basically do the horizontal
Correct,
row into a vertical column, right?
correct, correct. That's all it is.
Okay.
Yeah. And why that is required also we will see later on. But it is required. Okay, for transpose is required. Okay. All right. So if this is clear, then we will move on to our matrices. Before matrices also we have something called span. Very important. Okay. Where is span? Okay, span will also come in. I think here only. Okay. So basically, span is nothing but, let's just say, vector. Okay, vector you will plot, right? You will plot the vector, but vector has its own space. You, space in means it is nothing but the area in which vector can freely move. Okay, that is its vector space. Okay, like that you have something called span. Um, 1 second, where is it? Okay, so span is nothing but, see, when we talk about vectors, so these are our vectors, right? So v1 value we have, v2 value we have, v3 value, etc. We have multiple values. So in that we have something called uh, one is scalars. Okay, a1, a2, a3. Consider the example that I gave you in the very beginning, the example where in which you will take the step length to reach the gym. Okay, so those are your scalar values. Okay, and the vector values also you have. Vector values are nothing but in certain direction you take the step, right? Whatever the length you take, so um, that will be your vector. Now span is nothing but intersection of all those v1s and a1s. Okay, whenever you take so first of all here is the intersection of linear subspaces, and linear subspace in itself is nothing but, okay, linear subspace is nothing but, first of all you understand the space. Then I'll talk about space. Vector space, like I said, is nothing but the area in which vector can freely rotate, so all that will be its vector space. And subspace is nothing but subset of some larger space, some small space out of that. Okay, that is your linear subspace. Okay, now intersection of all the linear subspaces in a vector is called a span. Okay, it's, I know it's little difficult to understand, um, but you have to use a little bit of your imagination. Okay, maybe what we can do is we can just um, calculate and plot it. Maybe explain it by plotting, that would be better. 1 second. So let's just say again, v1 is my numpy. I think v1 we already have, v1 and v2. v1 v2 we already have. Okay, now what I'm trying to do is I'm trying to draw a 3D plot. Let me take that code, that way I don't have to type it multiple times. Okay, I will take this entire code. Okay, so in this code we have plt dot figure add. Okay, now I will add two accesses. Okay, one is I will say this, let this be v1, v1 of 0, and let this be v1 of 1, let this be v1 of 2. Okay, and let this be indicated in some color r. and likewise I will draw the second vector. Okay. Now here what I will do is I will take the coordinate system such that the coordinates exist from v of 0, um, some other array. Okay, I will add the values directly in that case. Let's just say this is 1, this is 2, and this is 4 comma, or let that be the same one, no need to change. Okay, these are our coordinate axis. Let this be okay. What was the value? I want to shift it to the okay. These are our two vectors. Let me make this as green maybe. Okay, so okay, these are two vectors. Okay, now span is nothing but, see this vector red. Red will rotate. Of course, I can't show you interactively because it doesn't allow me. We'll have for that we'll have to use a completely new library. So this red, if you move this axis, this red will rotate in certain direction, right? And this green will rotate in certain direction. When they both of these rotate, there is some common space, overlapping space. Okay, so that overlapping space is called as span. I know I know this again becoming difficult to imagine, but span is nothing but just the area, overlapping area between the linear subspaces of those vectors. Okay, um, anyway, so you can maybe, how do I show you? I'm just thinking out loud. um, okay, anyway, fine, okay, park it for now. Okay, span topic you park it for now. I will use plotly library and show it to you in the next class. Okay, don't worry about span. Okay, I will add something about span. But up until this point, is this clear? We will move on to matrices now.
Okay.
Okay, so matrices, again, there are matrices are nothing but representation of the same vectors only, but in rows and columns. I will add matrices here. So matrices, if you pay attention to, matrix is nothing but arrangement of numbers in rows and columns, nothing but rectangular array of numbers. Now array is nothing but vector. So what you do is you take multiple vectors, arrange them into rows and columns. So that will give you your matrix. Okay. So yeah. So here if you notice A1, A11, A12. So basically you have columns and you have rows, and each of them are represented. This picture is very important. The one that you see here. So it is important because to get the indexing, to understand the indexing, you need this. So in order to grasp to get the first element of the matrix, you have to pass the index as a11. Okay, a11 as in you have to pass two ones in square bracket, so that way you will get first row first column element. So likewise you have a12. Okay, to get the second element of the first row, always row value should be passed first. So first row is a1, second column is a2. Okay, so that way you will pass a square bracket 1 square bracket 2. That way you will get the second element. This will process will continue for the entire matrix. Again, matrices are of different types, right? So again we'll come to operations, but before that we want to talk about various types of matrix. You have um, types of matrices. You have row matrix where you have only one single row, column matrix so you have only one. If you transpose that row matrix, it will become column, although you can't visually see that on the screen, but you have to imagine. You transpose row vector, you will get column vector. Matrix where square matrix is where you have number of rows equal to number of columns. If there are 3 rows, there will be 3 columns, 2 rows, 2 columns, that way. Rectangular matrix is where number of rows are not equal to number of columns. Diagonal matrix is where only diagonal elements are present, rest are zero. Identity matrix is only where element identity where the diagonal elements are 1, rest are 0. Okay, symmetric and skew symmetric are quite interesting. So it's nothing but, first of all, it has to be a square matrix. Both symmetric and skew symmetrics are square matrices, wherein which if you take transpose of one, you will get the same matrix. Okay, then it is called as symmetric matrix, right? Symmetric matrix is where in which you have d transpose equal to d, which means if you transpose the same matrix, you will get the same matrix. Okay, skew symmetric is you transpose the same matrix, you will get negative of that matrix. Okay, that is your skew symmetric matrix. That is the difference. So these are some of the different types of matrices. Although our interest is not in the types of matrices, but rather on the operations. But I will anyway show you some matrices, how to generate some of the matrices. Here I'm gonna import again. I'm gonna import NumPy, and I'm also going to import random. You remember the random module that we studied? So this is going to help us here as well. Okay, so if you want to create a multi-dimensional matrix, you have two different ways. One, you can do it using NumPy array itself. Another one you can do is using from random dot rand int. We already studied this. Rand int is known to generate numbers. Okay, um, randomly, basically between 1 and 25. For this, I want to say how many numbers I want to generate. I want to generate 25, and to that I will reshape in the form of 5 comma 5. When I do that, I will get the matrix as mm, okay, random. Okay, let me change the importing value from random. Okay, import um, okay, let me do one thing. Let me take not the random module but numpy random. Okay, numpy random. From numpy random I'm importing the rand int. Okay, now I can pass rand int directly. Now I can generate the numbers. So I'm not using Python random, but rather I'm using a dedicated random module for NumPy. There is a little bit of difference, and the difference is this value. So you can provide how many values you want to generate, which is not available in Python random. So they have made certain modifications and made them available here. So that I am leveraging. Okay. So this, if you notice, is your square matrix, and yeah, and for this again I'm showing you different ways of generating. If I want to generate a identity matrix, I can directly type I eye I, like your eyes. Okay, if you generate I identity matrix and print it, you will get identity matrix. Okay, likewise you have zero matrix Z, n dot zeros. If you type, and how many do you want, you can specify the length and column. If you want 4 comma 4, you can type that as 4 rows and 4 columns. But if you want to modify the rows and columns, that also you can do. You will get the zero matrix. Okay, these are basic things. What happened? Did anyone rejoin? Archana. Okay, so these are your normal zero matrix. And if you want to grasp if you want to grab the diagonal elements, if you want only the diagonal 1 5 88 72 63, that also you can do using yes. You can take the numpy dot diagonal, sorry, you can create a diagonal matrix, sorry, my bad. Okay, d is equal to, you can take npi dot diagonal matrix of whatever the values you want to specify. If you want to have diagonal values are 1 comma 2 comma 3 comma 4, okay, and print the d, so you can have a diagonal matrix for on top of that zero matrix. Okay, and you also have something called triangular matrix, upper triangular matrix. Okay, that is not provided on that uh, website, but upper triangular matrix is a matrix that upper triangular matrix is a matrix wherein which all the elements above diagonal are greater than 0, rest of them are 0. Okay, likewise you also have lower triangular matrix L, wherein which triangular lower, right? So okay, so you have lower triangular matrix also. Okay, these are um, some of the matrices, the different ways you can generate the matrices. Now you can also concatenate the matrix, very important concept. Okay, concatenate we already know of a string. Okay, so if I type good plus morning, you will get good morning added together. This is called concatenation, right? Concatenation of strings. Likewise for matrices also, let's just say you have some matrix with same rows we need. Okay, u plus l, if I type u plus l, see what is happening, it is getting added. You are not getting the concatenation. Okay, this is addition of matrices, but for concatenation itself you have concatenate method. So for the point why I'm showing this is, you can't concatenate just like your strings. Okay, for concatenation you need to pass something like um, okay, u comma l, and you also have to, you also can provide the access. First let me pass this. Okay, you see, when you add these, when you make these as when you want to concatenate these two, join these two, it will by default do in vertical fashion only. If you want to do in horizontal fashion, you have to mention the axis equals to 1, very important concept. Again, passing the axis is very important when you want to join elements vertically. So here you're joining, sorry, you're joining elements horizontally. For horizontally you pass axis equals to 1. For vertical joining you pass axis as 0. Even if you don't pass, by default it has taken the axis. Okay, this is concatenation of matrices. Okay, clear?
Yes.
Okay, now the next question arises. See, it's difficult to visualize the matrices. Why? Because matrices consist of multiple vectors. Okay, what you see here is, this is one vector, this is another vector, this is another vector, this is another vector, this is another vector. So that way you have 10 different vectors here. 10 different vectors are stacked on top of one another to form a matrix. I think this we talked about in one of the classes where I was in Python classes, where we were discussing some similar topic. So vector, between vector and matrix, the difference is vector is only this. Matrix on the other hand is combination of vectors which are stacked on top of each other. Okay, this is a vector, this is a vector, that way and together they form a matrix. That's why you have double square also. For matrix always you will immediately you can identify matrix by seeing this double squares, starts with double squares, ends with double squares. Whereas matrix, whereas vector, okay, starts with single, ends with single. Okay, now how do you visualize this matrix? Now for this matrix itself, there is the only way you can visualize this in the form of colors. Okay, if you can do a line plot also, but that won't make sense. For example, let me do a plt dot plot. I will explain you this plt dot plot of s. If I do, see, what will you understand from this? You can't understand anything from this, because it's what you are seeing is vector representation of numbers. Okay, how many vectors are there? So many lines you can see, but that also are joined together irregularly. So which means you can't understand this. Okay, there is no way you can probably come up with clear understanding. Hence the much better way to visualize a matrix is using something called metric show. Okay, here what happens is each and every element of the matrix, okay, is represented in its own color format. Again, you can change the colors also, that's a different story. uh, so you can say c map equals to blues. I think blues. Blues is not a valid supported values. Okay, so blues is not a thing, but you can choose any one of them. Summer, I will choose summer. Okay, so summer. Okay, so something like that. You can choose rainbow. Okay, rainbow, or you can choose whatever the different ones are available. You can just get those values, and you can run whatever the scenario is. The point I'm trying to make is, again, this is extremely important concept. There is a reason why I'm showing you this plot. Okay, um, here if you pay attention to, where is a I will use l u, because u is much better to understand. See, our numbers numbers above diagonal line. Wherever there was diagonal, there are number, depends on this. Let me take the default one. Okay, now if you pay attention, so wherever there is zero, there is darkness. Okay, okay, and wherever the numbers are closer to zero, there also the numbers are. Okay, let me type u here, that way you can see and see. 5, there is 5, that's why it's closer to this color. Okay, again, this color 6 and 9, they are closer to the darkness. There are 256 colors, right? So if I change this as 256, I can't change. Okay, so okay, fine. So higher the value, it will be away from the darker. This concept is important because you are going to use it in multiple places, for calculation of correlations, for doing your computer vision, for doing the analysis
So,
of images. So everywhere you'll do this. Okay,
so if one of the values is 255, will it be white?
ideally it should be. Okay, I can create one. Let me see where it is. What all there is. Let me see if, okay, randomly we can generate. Where is yes? We can randomly generate and make use of this. 16, 16 is a 256, correct? Okay, so what I will do is generate 256, reshape it in the form of 16 comma 16. Okay, and then print b. See if you have some value closer to. Okay, let me not even give this d
Which
type. Okay, fine. D type
int?
int, yeah, int. 16 or 32 I will use.
Or if you manually create one.
Yeah, okay. So you have 156 here, right? So what I will do is I'll take this b dot match show plt dot match show of b I will pass. Okay. So here everything is 0, that's why you have darker shade. It is more like yellower shade. Okay, for this particular c map color map, uh, everything is in dark is closer to 0, everything is in yellow is closer to 256. As you can see, 115 is closer to 256. That has been represented as yellow color here. There is one more value much yellower than that, which is 116. Okay, this one. Okay, but if you want black and white only, you can accordingly choose your c maps, color maps. You will get that representation. Okay, is this
Okay,
clear?
sir. Thank you, sir.
Yeah. Okay,
Yes.
I think okay, let me try the same thing with different. I was trying with okay, let me take the cm dot blues. Yeah, this is a different color map, wherein which we are using matplotlib's color map. Here anything closer to 0 is, as you can see, white. Anything closer to 256 is dark blue. This way you can choose different color maps, so you'll get the results accordingly. Okay, um, is this clear?
Yes,
Basics
yes.
of this thing we have done, matrices. Okay, and leave this span for now. Okay, don't worry about this span. I will talk about it in tomorrow's class. So if this is clear, I want to stop till here. Okay, tomorrow we will continue where we left off. Tomorrow we have to see uh, from here, span, including span. So we will see addition, subtraction, multiplication, all these things, how to do using Python, NumPy, as well as imagination is very important here. You have to understand how these things are coming about. Otherwise, while doing your data analysis, not specifically data analysis, but rather when you're building the model, you won't be able to interpret the results if you don't imagine this. That's why I'm just saying. Okay, and I have added the links to this notebook here. Please go through and study that theory part. Okay, all right. If everything is fine, I'll stop it here.